In this problem, we're told an unwary football player collides with a padded goalpost while running at a velocity of 7.5 meters per second and comes to a full stop after compressing the padding and his body 0.35 meters. A. What is his deceleration? And B. How long does the collision last? Right? So the first thing you always want to do is draw what's going on. So we have this football player, right? Their initial velocity, right? They're going to be traveling at 7.5 meters per second. Right? And then at this point, they're going to hit this goalpost, right? They're going to still move a distance of 0.35 meters. Right, and then they're going to go to rest, right? They're going to stop. It's going to make them not move anymore, meaning their velocity, right? Their final velocity. Sorry, I wrote v sub 0. This is just v. So their final velocity is 0 meters per second, right? So this is basically what's going on. And so what we're trying to do is solve for the deceleration, right? Meaning we want to find acceleration, right? We want to find acceleration, and then we also want to find how long the collision lasts for, meaning we want to solve for how long this takes, or the time, right? So that's basically what's going on. Now what we want to do is write down the given. So what information are we told, right? What kinematic variables do we know in order to solve for the other two, right? So we know the initial velocity is 7.5 meters per second. We know how far it's going to travel, right? So how far the football player travels, which is 0.35 meters. We know the final velocity, right? It's going to end. He's going to go to a rest, meaning his final velocity is 0 meters per second. And what we're trying to do is solve for is the acceleration, right? And then we're trying to solve for t. So let's just go ahead and start with the first part. So for A, we're trying to find his deceleration. So basically what we want to do is solve for acceleration. So how do we do that? So what we're going to do is use one of the kinematic equations. And so notice we want to find A, right? So we're given v sub 0, we're given delta x, and we're given v. So if you look at equations 1 through 3, they all contain the variable t. So we're not going to use those. But if you look at this equation right here, which is v squared equals v sub 0 squared plus 2a times delta x, notice that we have delta x, we have v sub 0, and we have v, so we can just solve for a. So that's exactly what we got to do. We just got to plug in. So v is 0. 0 squared is still 0. So it's just 0 equals v sub 0 squared, so 7.5 squared, plus 2 times a times delta x, which is 0.35. So I'm going to minus this to the other side, right? So we can get a by itself. So we're going to get minus 7.5 squared is equal to 2 times 0.35 times a. To get a by itself, divide by 0.35 times 2. So basically what you want to do is do 7.5 squared, right? And keep in mind it's negative, divide by 2 times 0.35. And if you do that, you get a equals minus 80.357. So you can round however you want. You can just say minus 80.4. So minus 80.4, and then the units are meters per second squared. So keep in mind his deceleration, right? His acceleration is negative 80.4, which indicates the negative sign is just the direction, right? So his deceleration, he's going to decelerate at a rate of 80.4 meters per second squared. But you can just say the acceleration equals negative, right? That just indicates that it's decelerating at that speed. So this is basically your answer to A, or you can just say the deceleration is 80 at a rate of 80.4, right? So that's basically your answer to A. Let's move on to B now. So for B, what we're trying to do is solve for how long does the collision last. So we're trying to find time, right? So I'm actually going to write this in here, minus 80.4 meters per second squared. So what we want to do is solve for t, right? How long it lasts. And so notice we have 4 kinematic variables now. So you can use any of the equations except for the one we just used, right? Because it doesn't even contain t, right? So we can't solve for it if it doesn't exist in the equation. But we can choose any of these, right? Because we have every variable now. So the one I'm going to use is the one at the top, v equals v sub 0 plus a times t, just because I think it's the easiest. So notice we have v sub 0, and we have a, so we can solve for t. So all we got to do is just plug in. So v, right, is 0, which equals v sub 0, which is 7.5, plus a negative number, right? So plus is just, so it's going to be minus 80.4 times t, which is what we're solving for. So minus 7.5 from both sides. Minus 7.5 equals minus 80.4 times t. Divide by minus 80.4. Right, so you're going to get t equals, and then just do 7.5 divided by 80.4. Right, because the minus signs cancel. So when you do this, you're going to get t equals 0.09328 and so on. I'm just going to round to 0.09. So 0.09 seconds, right, because this is time. So 0.09 seconds. This is going to be your answer, right? So how long it's going to take for it to stop. So this is your answer to B. This was your answer to A. And yeah, so these are your answers. And hopefully you found this useful.